Here we go. Here's a video about determining if a relation is a function and finding the domain and the range of a function. A definition that you can use for a function is a relation in which each input is paired with exactly one output. If you've learned this before, then you know that graphs must pass. Hopefully you remember. Many students will tell me it's the pencil test. Roll a pencil across your desk is what they'll say to me. But remember, that's called the vertical line test. To pass the vertical line test, a vertical line, for example, if I had this graph. And I drew a vertical line through every part of this graph, and I'm going to try to do that with my left hand. So there's a vertical line. It passes through once, so at this point it passes the vertical line test. Once you look here, though, that goes straight down. So this portion of the graph is vertical. My vertical line passes through more than one point on the graph, so this is not a function because it fails the vertical line test. So to pass the vertical line test, a vertical line could only pass through the graph one time. Also, here's something that I'm sure your teachers have said to you. To be a function, if you have a table or a relation where you have just a list of ordered pairs, no x values can repeat. It's okay if your y values do, but your x values cannot repeat. Okay, so we're going to look at questions 1 through 5 and determine if that particular relation, well, 1 and 2 are relations, 3, 4, and 5 are graphs. Determine if they're functions, and we're going to explain why or why not. Okay, so as I look at this table here, is every x coordinate, do any of the x values repeat? -1, 0, 2, 3, 4, 5. No, none of the x values repeat. So I'm going to say yes, it's a function. And the reason, you could say each input is paired with one output. You could also say each input is paired with one output. You could also say none of the x values repeat, and that would be an explanation that would be sufficient. Okay, so here, let's look at number 2. Is this relation a function? 6, 10, -7, 3, 6, -4. And the answer is no, because 6 is paired with 10, and 6 is also paired with -4. So this one would be no, it is not a function. And my explanation is 6 repeats. No x values may repeat. So there's those particular problems and why those are functions. Number 3, 4, and 5. So these are graphs. And what did we say just a minute ago? How can you determine if a graph is a function? Well, it has to pass the vertical line test. If you look, I have 1, 2, 3, 4, 5 coordinates in my graph. Would this pass or fail the vertical line test? Well, let me draw some vertical lines. Forgive me if they're not straight, because I am drawing with my left hand. I missed that one, pretend like it went through it. There's a vertical line through that, the axis. Pass the vertical line test? Yes. Every one of my pink lines only pass through one point on the graph, and so yes, it is a function. And you can just simply say, whoops, function. It is a function because it passes the vertical line test. Okay, how about question number 4? Let me draw one vertical line. Sort of vertical line. Look, this vertical line goes through this point and this point on the graph. It goes through 2 points. So it fails the vertical line test. No, it is not a function. It fails the vertical line test. Okay, so sorry that's sloppy. I think I crossed that T. Okay, my last one, what do you think? Yes or no? Oh, and by the way, this dot is not part of my graph. And that's what I get for not writing in a pencil when I drew that graph. So that dot is not part of the graph. Is that graph a function? Would it pass or fail the vertical line test? I'm going to draw some vertical lines really quick. What do you think? Each of those pink lines, did they go through only one point on the graph? Hopefully you said yes. Yes, it is a function. It passes the vertical line test. That's how you explain. Okay. Now, the last 2 problems asked me to find the domain and the range of the function graphed. Remember, your domain is your set of x values, and your range is your set of y values. Your domain is how far left to right your graph goes, and your range is how far up and down your graph goes. So as I look at this, my domain, when I have both of these, I need to write ordered pairs that I can see. Right now I see -1, 2 here, and I see 1, 0 here, and 2, 2 here. Now, this graph and this graph are very different. This is a graph that has many ordered pairs that we could not list. So we would use inequalities to represent our domain here, our x's. How far left to right does this graph go? Well, the farthest left x value I have is -1. And the farthest right that it goes is +2. All values greater than or equal to -1, and I know that says less than or equal to, but x is greater than or equal to -1, and all x values less than 2 are the domain for this graph. Now, how about the range? How far up and down does it go for the y's? 0 is the lowest y I have here. What's the highest y that I have? 2. So my graph, my y, 0 is the lowest y, 2 is the highest y. So y is greater than or equal to 0. Y is greater than or equal to 0. Y is also less than or equal to 2. And this should be an equal to as well. I apologize for that. So I have x is greater than or equal to -1 and less than or equal to 2 for my domain, left to right. How far up and down? From 0 to 2. And those are included. So that's my domain and range for number 6. Number 7, I need a list of ordered pairs. This first ordered pair looks like -3, 2. Then I have -2, 1. Then I have 0, -1, 1, 0, and 2, 1. Okay, so now my domain And when you're doing domain, all you have to do, a domain of just a relation of ordered pairs, all you have to do is list the x's for the domain, -3, -2, 0, 1, and 2, and then list the range. And it's best to put them in numerical order. The x's were in numerical order because I went from left to right. Numerical order for my y's, I have -1 is my smallest. Then I have 0. Then I have 1, and it occurs twice, but I don't have to list it twice. And then I have 2. So that's my range for that particular problem. Okay, I hope that helps. I have one more problem to go with this lesson for determine if a relation is a function and find the domain and range. The problem is a word problem, and most students do not care for word problems, but it's a relatively simple word problem. It says the function y equals 4x represents the number of pages in a novel that Fred can read per minute. Our first task we have to do is identify the independent and dependent variables. We have two variables. We have x, which stands for the number of minutes that Fred is reading, and y, which stands for the total number of pages in which he has read. So I want to figure out which one of those is the independent variable and then which of those is the dependent variable. Well, hopefully you can think about it like this. The total number of pages that Fred reads depends on the number of minutes in which Fred is reading. So dependent, y is dependent on x. The total number of pages depends on how many minutes he's reading. So my dependent variable is y, and that stands for the total number of pages read. And then my independent variable is x, and that stands for the number of minutes. Fred is reading. So that's my independent and dependent variable. Independent x, dependent y. Okay, now it says if the domain, remember domain is your x's, if the domain is 1, 2, 3, and 4. So, I'm so sorry, I keep hitting that. So that means 1 minute, 2 minutes, 3 minutes, 4 minutes. What is the range? Well, here's the way I would set this up to work this out. So my domain is 1, 2, 3, 4. My range will be what I get when I substitute these values into the function. So y, or the number of pages in which that were read, comes from substituting 4 times 1 is 4. So after 1 minute, 4 pages are read. Substitute 2 in, the domain of 2, into the function. 4 times 2 is 8. So after 2 minutes, 8 pages are read. Substitute 3 in. After 3 minutes, 12 pages are read. And then the last one, 4 times 4 is 16. After 4 minutes, 16 pages are read. So the range is 4, 8, 12, and 16. There we go. Hope that helps.